In today's activity, you're going to be looking at an introduction to factoring, specifically using something called GCF. And so to get credit for today's activity, you do need to do all of the examples that are in this Desmos activity. Everything is self-checking. But as always, if you get stuck on anything, please do go back over to your breakout room in Zoom, hit your Ask for Help button, and I can help you out through that problem. But let's check out first some vocabulary and some introductory stuff to get you started. So here we go, some factoring vocabulary. Well, we need to know what factor is to start out with. So factor technically is anything that you can multiply with another number or another variable that will create your term. So if we look at this more mathematical terms, we could say that it's each of two or more numbers, variables, or algebraic expressions. That is multiplied. So we're going to be looking today at how we can determine, what those factors are and actually factor out some expressions. A polynomial, again, you've probably heard this term before. If you think of the word poly or the prefix poly, means many. So specifically, a polynomial is an expression with two or more terms, hence the poly. And don't forget, when you're looking for, how many terms you have in an expression, your terms are always going to be separated by either an addition sign or a subtraction sign. If you do have a multiplication sign written in, which isn't going to be too often, that is not a separation of terms. So for example, if you had 2 times x, that's still considered just one term, versus 2 plus x is actually two separate terms. Okay, next term, factoring. So the act of factoring is really separating out the things that you could multiply to make that expression. So a little bit more specifically, we're going to separate on an expression to find the factors, the things that you'd have to multiply to make it, that when multiplied, state the polynomial as a product. Again, just another word for what you get when you multiply. You could also describe this as kind of undoing a multiplication. Okay, prime. Now you've heard the term of prime number, where you have only the factor, or the only factors of that number are 1 and itself. Well, we can think of this too with polynomials. So if we cannot factor a polynomial, if they don't have any common terms, we can call it a prime polynomial, or specifically something that only has factors of 1 and itself. And then our last piece of vocab for today, the greatest common factor, or what you've seen as GCF. So GCF is the largest factor that is common to all terms in an expression. Now, this could be, two numbers, or this could be a combination of multiple terms that could have numbers and variables in them. Okay, if you need to, go ahead and pause the video and copy down your vocab, especially if you're not using the organizer. Okay, let's look at a couple examples where we're actually going to find the GCF of two numbers. Here we go. So the two numbers we're going to check out are finding the factors of 24 and finding the factors of an expression x, y squared, z to the 4. Now, there are a few different ways to do this, and so I'm going to show you one method now, and then I'll look at a second method where we can write out our factors that might be a little bit more helpful when factoring. But right now, let's just get an idea of, well, what are our possible factors that we can even consider? And so earlier in, Algebra 1 or previous classes, you've done something called a factor tree. And so all that is we are taking our 24 and we're trying to split it up into all the possible numbers that we can multiply. So 24, and again, there's multiple ways we could do this. One of the ways we can get 24 is by doing, let's do 3 times 8. I can't break down my 3 anymore, but I can break down my 8 into 2 times 4. And that 4 breaks down even further as 2 times 2. So if I was going to list all the prime factors, then I would be just listing the numbers that are at the ends of the factor tree. So I had 3 2s at the end, and I had 1 3. However, when you're going to be factoring out expressions and looking for a GCF, you don't want to just consider the prime factors. So let's make a separate list of all factors. And so for here, I start thinking about the prime factors and then work my way up from there. So think about your 2. What happens if you divide a 2 out of 24? Well, that would give you a 12. Okay, what other numbers divide out of 24? Well, I'm just going to kind of go up through my numbers. So I could consider 1. So 1 times 24, you know, your prime factoring almost. But we're not going to use that as often today. You might see that in a future lesson for this unit. I could do 3. 3 times 8 makes 24. That's the one I use to start my factor tree. What other factors are 24? Well, what about 4? We could do 4 times 6 as well. Let's see, any other factors? Because next one up from 4 is 5. That's not a factor. And then next one up is 6, but we've already stated that as a factor with 4 times 6. So we pretty much have all of our factors for 24 listed. So we've got our prime factors are 2, 2, 2, and 3. Or we can consider all our possible factors. We had 2, 3, 4, 6, 8, and 12. So we need to think of this a little bit differently with a variable expression. So we have x, y squared, z to the 4. And so there are a bunch of different ways that we can separate this out, but think in terms of what that exponent means. So your exponent on any variable just means how many times you've really multiplied that together. So if I'm thinking about my prime factors, all the things I'd have to multiply together completely to make that expression. So let's list this out. So our prime factors, well, x is just x. Officially, if you want to think about it, your implied exponent on that x is just a 1. And I only have one x multiplied in. Y squared means how many y's are multiplied. Okay. So we have 2 y's getting multiplied with the y squared. And so z to the 4th means how many z's multiplied. So that's 4 z's. 2, 3, 4. And so if we were going to think of, well, what are all the possible factors that we could use? We have to consider all those combinations. So there's only one possible combination of x's. There's just x. Now we could use possible combinations of y's like y or y squared. And then again, multiple combinations of z. We could have z, we could consider z squared, we could consider z cubed, and we could consider z to the 4. So think about the fact that all those possible things are factors, not just the prime factors that we can break everything all the way down into with our factor tree. Okay, so now you're going to go ahead and try out the next 2 examples on Desmos. And again, if you get stuck on those examples, ask for help at the bottom of your Zoom screen and I can pop in and help out.